Hello everybody, this is Miss Abney. Today we're going to look at topic 2, lesson 7, example 1, determine the number of solutions. We're going to be looking at linear quadratic. We've seen linear and linear in the past, and we've seen just linear, I believe. So this is our first time really looking at the linear quadratic system. So how many real solutions does this system have? We're going to look at this two ways. We originally looked at these graphically. I'm going to show you algebraically. The book does graphically, so we're going to look at that as well. So let's go to my notebook. Let's hide this guy here. And what I'm going to start doing is I'm going to start with substitution. I'm going to make that x squared equal to 2x. Basically, I'm substituting this y equals into that y. Subtract the 2x, and I am left with x squared minus 2x equals 0. Okay, now this is a binomial, and in the past with the binomials, we'd move one to the other side and take the square root. But both of these terms have x as a part of it. So I'm going to factor that x out. I'm going to look for the greatest common factor first. Always see if there's a greatest common factor before you do any other type of factoring work. So in this case, we have the greatest common factor of x. I'm going to do x minus 2 equals 0. And then according to the zero product property, each of these becomes 0. And we get x equals 0 and 2. But we didn't have to find the solution. We just had to know how many solutions. So in this case, we have 2. You could have also done the discriminant. We've talked about that before, and we'll use it for the next example, where a is equal to 1, b is equal to -2, and c is equal to 0. And we would get 4 minus 4 times 1 times 0, which would be 4, which is greater than 0, so that's 2 real solutions. So you could have done it that way as well. But you would have to get it into this format first. Okay, so that's algebraically. Let's look at this graphically. So the graph seems to show the quadratic function and linear function intersect at 2 points, and those intersection points are the solutions. So the system has 2 real solutions. So a solution to a system of equations is an ordered pair x and y that produces a true statement in all the equations of the system. In the graph, the solutions are the coordinates of the intersection points. We've talked about this before, now you see it again. Okay, so part 2, how many solutions can there be for the linear quadratic system? How does modifying the linear function in the system affect the number of solutions? So I actually was prepared today. I pulled this down right away. I'm going to use the discriminant for this. So this is that idea of the b squared minus 4ac being either greater than 0, less than 0, or equal to 0, and the types of roots that you get. All right, so I am again going to do substitution. I'm going to do x squared equals 2x plus b. I'm going to get one side as 0, the other side the standard form for the equation. So this is going to be x squared minus 2x minus b equals 0. I just subtracted this side from both sides. All right, my a in this case is 1, my b is -2, and my c is -b. Putting it into the discriminant, I'm going to find the one real solution, the one, because that's an equal one, and then we could determine the domain of the other ones from them. So b squared is going to be 4 minus 4 times a times b, which is -b, and that's going to equal 0. This is one real root. Okay, so 4 times 1 is 1 times -b is -4. Negative times negative is a positive, so this is 4 plus 4b equals 0. Subtract the 4 from both sides. We get 4b equals -4. divide by 4, we get b equals -1. So when b is equal to -1, we have one real root. What happens if b is, let's say, -2? So I'm just going to actually substitute -2 in for b. So 4 plus 4 times -2 is equal to 0. It's not equal to 0. It's equal to what? So 4 times -2, that's 4 minus 8. It's going to be -4, which is less than 0. So when b is less than -1, we have two complex roots. And that just leaves b greater than -1. And we could choose a value like 0. So if I did 0, 4 plus 4 times 0, well, that's 4. 4 is greater than 0, so that's 2 real roots. All right, so these are the conditions that will give me real roots and imaginary roots with the line. Again, we can do this graphically as well. And that's what they do here. So they usually can slide this over, but use the tool to explore the different values of b. Let's see if I pull this out and do this. Here we go. So I can use this where b equals. So notice how they put this in decimals, x squared, and then y equals 2x plus b. You can actually put that variable in, and then they'll have you basically use a slider for the b. I think this just pops up, but I'd have to explore that a little bit more. But we can start looking. So right now we don't have any intersecting points. These are the complex roots. Since we don't have any intersecting points, we have those complex solutions. And as we get closer and closer and closer, all right, so now when b is equal to -1, we have this first point of intersection right there. And then we keep going, and now from that point on, we have 2 points of intersections, and we'll have that going on forever and ever. If I zoom out, you can still see there's 2 points of intersecting. All right, so let's go back to here. Up here. Sorry about that. And then part 2, solutions. So when b is greater than -1, there are 2 solutions to the graph and intersects at 2 points. When b is equal to -1, there's one solution. The graph of y equals 2x minus 1 is a tangent to the graph of y equals x squared. So remember what a tangent means. You learned that back in geometry. It's touching at one point. When b is less than -1, there are no solutions. For example, the graph of y equals 2x minus 8 does not intersect the graph. So there are no real solutions. Visually inspecting the graph suggests that there is no way for a line to cross the parabola more than twice. Thus, the system of linear functions and a quadratic function may have 0, 1, or 2 real solutions. That's the same one. All right, so from here, we want to find the real solution. So you might have 0 real solutions, 1 real solution, or 2 real solutions of the system of equations. And I would recommend trying it graphically, and I would recommend trying it algebraically. I hope you have a fantastic day, and I'll see you in the next video.